wording have to just generally being like more usable for like larger and mainstream applications. So to start off, and I'll talk about the thing that you need to download before you even start using Ethereum, wallets. Right? So wallets are very important. A wallet is the software that you use to read the blockchain. It's the software that you use to interact with the blockchain. It's a software that requires a lot of trust. If you have a wallet and the wallet breaks, then you might lose all of your cryptocurrency, or all of your cryptocurrency could go to some hacker. It's something that's like very important, and it is kind of the interface through which all of the blockchains and guarantees and benefits are often provided. So it's important. So wallet security, right? This is the kind of big problem that this space has had for probably a very long time. Right? So there's two kinds of wallets that we've had historically. The first kind of wallet is a centralized wallet. So a centralized wallet basically means there's some trusted company that has your keys, and they're the ones that hold your coins, they're the ones that manage your coins, and you interact with the wallet just like you would interact with any other web application. So this works well when it works, but in the history of cryptocurrency, there have been so many times when it did not work. So my Bitcoin, this is the very first kind of centralized wallet that existed in 2011. After about 2 months, it got hacked. Maybe it got hacked. Maybe the owner pretended it got hacked and ran away with 51% of the money. We don't know. So, and from time to time, things like this happen. And like the reason why it happens is basically because you're putting a very large amount of centralized trust into one actor that often does not deserve it. So like centralized wallets are at one extreme. We can also take the kind of completely opposite other extreme. And this is what I call user sovereign wallets. So user sovereign wallets are probably the wallets that are more popular today. And a user sovereign wallet basically means you have a program, the program runs on your computer, and you have a private key on your computer. And this private key controls, controls the coins, and if you want to send transactions, a signature is directly made on your wallet, and the transaction gets broadcasted over the network. So this is nice because it does not require any trust, but it's also limited, right? So I have on the right side of the slide here, it's difficult to read, but another kind of horror story that this is from Bitcoin Magazine, an article I wrote about 6 years ago. And basically what happened here is there was someone who had some coins in a wallet, and he downloaded an application. And this application was actually made by hackers, and he did not know this. He thought he was just running a regular application. And what happened is that this application then started recording every key he typed on his keyboard. And so by doing this, it captured his password. It captured the password that he used to decrypt his wallet. And as soon as it got his password, it decrypted his wallet, it extracted the private key, and it sent all of his person-sized coins to some address. So basically, in both of these cases, right, it's like one-factor authentication. The coins are controlled by some key, some one kind of single central point of failure, and this one central point of failure, whether it's you or someone else or some centralized system, can fail. So this is one problem, right? And so this is one problem. Now, how do we solve this problem? So what we have more recently is there's been a lot of interest in something that people are starting to call smart contract wallets. And what a smart contract wallet is it's a a wallet where instead of your coins and your assets and all of your activity happening through an account that's controlled by a single key, all of your activity happens through an account that is a smart contract. So it's not a regular account that holds their coins, it's a smart contract that holds their coins. And the smart contract has rules for how those coins can be spent, for how any activity coming through that address can happen. So one example of this is multisig. So you have 3 keys and you need 2 of them to agree for a transaction to happen. Another option is you could have 1 key, but then you also have a set of backup keys. You might have 5 backup keys, and you might distribute them to some institutions, you might distribute them to your friends. Like, you can choose how you distribute these 5 keys. And if you lose your key, or if something happens to your main key, then like maybe 4 out of 5 backup keys can work together and to switch your main key to something else. Right, so like, this is called social recovery sometimes. So with these kinds of techniques, basically the idea is that you can kind of really step up security to the next level. And the reason why is basically that there is no single device where if that one device gets hacked or if that one device gets lost, you lose access to your accounts completely. So you don't have one central point of failure anymore. Instead, like maybe 3 different things or 5 different things need to fail at the same time for you to kind of actually lose access to your money. Now, you can do even more clever things. So to give one example, the Ethereum Foundation has its coins in a multi-sig wallet. So it's a wallet that has 7 keys. And to spend less than 1,000 coins Ether per day, one of the 7 keys can do it. But to spend more than 1,000 Ether per day, you need 4 of the 7 keys to assign a transaction to be able to move that much funds and send it to another address. So like lower amounts, more convenience, higher amounts, more security. So what smart contracts give you is they basically give wallet designers this large level of flexibility to make design wallets that actually do have kind of higher levels of security than like what we have today, and like something closer to, say, what you would expect from a bank, but without the centralized intermediary. So there's unfortunately, somehow the slide that actually shows some examples was not included here, but there's a number of wallets that have been starting to do this recently. So Argent Wallet has been doing this, and like they've done a good job of really trying hard to make this kind of scheme very easy to use. There's a couple of other projects that are doing the same thing. So this is something that's making a lot of progress, and there's other things that are kind of progressing forward at the same time to make it easier. And so one example of this is that there is something called the gas station network, which basically makes it easier to pay transaction fees for applications kind of in non-standard ways. So for example, the receiver can pay transaction fees, smart contract can pay transaction fees, and these kinds of things. So about like maybe 1 year ago, there weren't really any wallets that were smart contracts by default. Now there are, and I think in 1 year there will be a lot more. And so, wallet security is definitely important because, ultimately, what good is having even an infinitely secure blockchain if the individual users and the software that those users use to interact with the blockchain are completely insecure. So this problem, I think, is very quickly starting to be solved. So this is one problem. Right? The one problem is you have private keys, and how do you decide whether or not you're allowed to send a transaction? There's another problem, verifying the blockchain. So who here runs a full Ethereum node? Not too many people. So if you wanted to ask why not, I think one of the answers that many people would give is running an Ethereum full node takes up too much space, right? And it takes up too much computing power. Like you can run an Ethereum full node on your computer, but it's difficult, right? It requires a long time to set up. It requires you to keep it running, and if you turn your computer on, it takes maybe half an hour for it to sync the chain. So it's not very efficient. Now, because of this, basically, what a lot of people are resorting to right now is completely centralized approaches. So in Fura, it's this centralized service that it has an API, and you can ping it, and it tells you things about the blockchain. So basically, there's a very large number of Ethereum applications that, instead of talking to a local Ethereum node, just talk to one particular node run by a subsidiary of Consensus. So this is, and of course, a lot of people are not happy about this, right? It's like one kind of central intermediary that many users of the blockchain are relying on. So how do we solve this, right? I think the answer to solving this is better light clients. Now, light clients exist today, and so, for example, if you run Geth, if you run it with sync mode equals light, then instead of downloading all the blocks, it just downloads all the block headers, and it's more efficient than a full node. But it's still not efficient enough, right? It's still not efficient enough to run a browser extension, for example. And so people are trying to make light clients better. One example of this is there's something called Incubed, which basically uses a kind of a unique kind of a layer 2 proof of stake deposit system to build very light clients on top of Ethereum. And this is something that is theoretically usable today, but it's still very new, and it's something that you could potentially use as an alternative, right? So this is a light client, and it is a fully decentralized system. So this is the near future. I am going further into the future. Ethereum 2.0 is designed from the start to have light clients that are as efficient as possible. So here I have a little mini diagram of how light clients work and how the light client syncing process works. But basically, one of the benefits of proof of stake is that instead of needing to kind of sync a very large number of block headers, you can verify a single day, an entire day's worth of history, kind of indirectly by just kind of skipping from the beginning of the day to the beginning of the next day. And so a light client only requires maybe 10 to 20 kilobytes per day of bandwidth. Right? 10 to 20 kilobytes per day is tiny, right? It's like people had that much bandwidth in 1980. So there's teams that are starting to implement this now, and this is Ethereum 2.0 only, but basically the light client design is much more efficient in many ways. Now, in the further future, Now, in the further future, there's even more advanced designs for light clients, and these designs for light clients basically allow even light clients to detect when blocks are invalid, for example. So there's a combination of techniques that you can use to detect when a block is invalid, or to detect when the data inside a block has not been fully published. And you can do this without actually downloading and checking all of the data yourself. So in the further future, with these kinds of protocols, we can potentially increase the security of a light client to be very close to the security that a full client has already. So this is all wallets, right? So wallets basically having kind of very high security guarantees is something which is difficult today, but which has been becoming easier and easier with like basically every month. Now let's go to applications, right? So decentralized exchanges. So on the left, you have a decentralized exchange and what it looked like in 2017. And I remember I tried to trade with like some of these platforms in 2017. And it would always be complex, it would be difficult, you would need to like sign 4 different transactions, one to approve, one to deposit, one to do some other things, and it would be complicated. 2019, like you have Uniswap and you have like other platforms, and you basically have on-chain decentralized exchanges that let you trade from one token to another token in one click, right? You click the button and then MetaMask opens up, it asks for a confirmation, you say yes, and you send the transaction, and that's it. So this is already much better, and I think the one kind of frontier that we haven't gotten to yet, that we will get to, is cross-chain decentralized exchanges. So the problem with cross-chain decentralized exchanges and why they're more difficult is that a decentralized exchange between Ethereum assets is something that is easier to build because you only need to understand the Ethereum protocol, you only need to understand ERC20s, and because everything is on the same chain, you don't really even need to think about the chain, right? When you're inside the chain, you don't really need to think about the chain that much. So cross-chain is more difficult because you have multiple protocols, multiple chains, and you need one chain to verify something happening on the other chain. Now, this is a project that's doing auctions. So basically, this is a kind of one-way decentralized exchange where basically what they're doing is they have an auction, which is an Ethereum smart contract where it's selling Ether, and the price of it's selling Ether for Bitcoin, and the price of the Ether starts off very high, but it slowly decreases over time. And if you have Bitcoin, then you can send a Bitcoin transaction to a specific address, and then you send a proof that that transaction happened into the Ethereum smart contract, and this proof can be verified inside of Ethereum, and if it verifies, then you automatically get the amount of Ether that you paid for. So this is not too complicated, but it's still kind of pretty technically impressive. Basically, it's using a smart contract on the Ethereum blockchain to verify a light client proof that a transaction happens on the Bitcoin blockchain. So, and it's using this to basically implement an exchange between the two systems. Now, this is just one example, but I think like in general, trading assets between different chains still seems to be the kind of final frontier where decentralized approaches are still very technically difficult. But I think in the future they'll become less and less difficult, especially as blockchain protocols kind of standardize and improve light clients more and more. Right? So light clients are not just important to have convenience for users. Light clients are also important so that chains can talk to each other. Light clients good. So DAOs. Who here remembers the DAO? Okay, well, only 4 people, that's good. So, DAOs were the decentralized autonomous organizations, kind of smart contracts that can control digital assets and that kind of implement a system of rules that allows a group of people to control those resources together. Have been this dream of Ethereum for a long time, right? I published this article where I introduced the term DAO well, I introduced the term DAO, Dan Larimer introduced the term DAC, and then that went into bit shares, and then there's longer stories. But and at the time there was like a lot of excitement about this. So you can have these sort of decentralized autonomous things that are just running, and the infrastructure that they're running on is this kind of fully automated thing. In 2016, 1 year after Ethereum launched, people started to build it. Right? People decided that, hey, people were so excited about DAOs, let's try to actually make a DAO. The problem is that at the time, the technology standards, the practices, so basically everything about kind of writing smart contracts was not very good. Not much technology, not much knowledge, not much experience, and they built this DAO, and basically a kind of decentralized coin voting investment fund, and they expected it to get maybe a few $1 million. Instead, it got $220 million, and then it lost $60 million because it got hacked. Now, after this happened to DAO fork, after this happened ETC and many other fun things, but it was this big learning experience, and like for a couple of years, people definitely got scared of writing contracts that have a lot of money in them. Now, finally, I think the fear side of it, the new DAOs are also simpler. So the original DAO had like thousands and kind of for special purpose doing things. So people are still, I think, kind of excited about this idea, right? That like, how about we just get a group of people, and this could be anyone from anywhere in the world, kind of pull their assets together, put them into a smart contract, and like collectively just like use that to do things. Could be funding public goods, could be doing some kind of profitable project, could be investments, could be many things. And the tools for making that practical, I think, are kind of finally starting to be here, which is really nice. Now, smart contracts are also being explored for other use cases. So, I mean, on the left here, this is an idea I published about 1.5 years ago, what I call a DAICO. And the idea here is basically that, like, there's ICOs, and people who are making projects that have coins in them often like to do an ICO to get money. ICOs have a big problem. Basically, the incentives are like completely misaligned, right? Like in a normal project, you do the work and you get money. In an ICO, you get money, you get more money, you get even more money, and maybe you work. So the goal of a DAICO is to try to kind of combine elements of decentralization into an ICO and kind of fix this misalignment. And the idea here is basically that this ICO happens, but instead of the funds going to the developer, they go into a smart contract, and the participants, the people who contributed the money, basically get to vote on like how quickly the developers get the money, and they can also vote to just cancel the whole thing and kind of refund the rest of the money proportionally to themselves. So this has actually been used a couple of times, but not too much yet. But there's also another idea that I find really interesting. That's kind of very similar, except here what happens is that, like, once again, imagine there is a project, and that project needs to collect funds. Well, instead of sending money, so you basically what you do is you take some DAI and you deposit it into a smart contract. And let's say if you deposit 100 DAI, then you can always get 100 DAI back. So there's never any kind of risk of loss of principal. So you just deposit your money, right? Now, then what happens is that DAI gets put onto Compound, and it gets invested on Compound. Compound creates interest for the DAI. and the interest for the DAI gets automatically sent to the project developers. So basically, it's like taking DAI and kind of staking it on a project and kind of giving that project some amount of kind of regular recurring revenue. So the nice thing about this approach, right, is that it is kind of like investing over time. But first of all, like, there is no instant gratification, right? Like, if you launch a new project, people have to sign up, you get a little bit of money at first, then if more people sign up, you get more money, but you only kind of get it in pieces over time. And if you make your people unhappy, then they have the right to withdraw the money or kind of redirect the money to another project at any time. So this example is interesting because it uses smart contracts, but it also uses an entire ecosystem of smart contracts in very clever ways. So it uses MakerDAO, it uses Compound, it is a smart contract itself, and it kind of glues these different pieces of the ecosystem together to create this kind of new approach that probably would not exist on its own. So there's basically what we're seeing is kind of more and more experimentation with these kinds of ideas. And like the nice thing here is that the ecosystem is finally kind of getting to the scale where like it makes sense to start, and we are starting to see a kind of more infrastructure for writing code and generally building the tools to make these kinds of things like easier to create. Going back to simpler things, right? So actually using it, like we can talk about these kind of ideas that are really nice in theory, but we can also talk about kind of how we use Ethereum today. So who here has used the Ethereum blockchain in the last month? Okay, that's more people than have heard of the DAO. Who here has not used the Ethereum blockchain in the last month? Okay, so most people have not used the blockchain at the same time. That's good to know. So out of the people that have raised their hand for something, like it seems like most people have used the blockchain recently. So who here has used the blockchain in the last month for something other than payments? Okay, still many. ENS? Cool. Trading between different assets? Okay, still quite a few people. What about, did anyone here participate in the auction that the Ethereum Foundation ran to sell 50 DEFCON tickets on chain? Okay, no one here, but like 50 people did. Oh, sure. At least 50 people did. Right? So the kind of uses of the blockchain that we're actually kind of seeing in practice, like they're definitely a step behind kind of the bleeding edge of what you can do theoretically, but they're still expanding, right? So first of all, like for a very long time, the Ethereum Foundation has used just cryptocurrency for payments. Cryptocurrency is very convenient for sending money to different people. It's very easy, and regardless of like what country they're in, which is very nice. There's advantages to using DAI for payments. Like basically, one of the big ones is that if you're sending a kind of payment that like goes into escrow and might need a refund, then like refunds work much better if you do them in a stable coin instead of doing them in some like very volatile asset that might go up or down by a factor of 2. ENS is something that's starting to kind of see more and more usage. I use ENS on Vitalik.eth. Digitally representing different kinds of assets, like conference tickets is one example, badges, so like on-chain tokens saying, like I participated at some event, I donated to some charity, I contributed to some open source project. I mean, all of these things can be just like done as records either on the blockchain or through some kind of decentralized identity system connected to a blockchain. So more and more of these things kind of are starting to actually happen, right? And the other nice thing is that we're seeing more and more kind of infrastructure for working with these things and making them easier to use. So I guess for applications, what we're seeing is like nothing very mainstream yet. But I think a big part of the reason why we're seeing nothing mainstream yet is just like, one is usability issues, which I think are being solved. Another big one is scalability issues. And scalability issues are a big problem, right? Basically, the Ethereum blockchain for a very long time had a gas limit of 8 million, and the blockchain was like almost 100% full. And like people were using out of the 8 million gas in a block, people were almost always using up almost the entire 8 million. There's just always applications that wanted space. And so 1 week ago, like the community started yelling at the miners and telling them, hey guys, increase the gas limit. And the miners, or at least 53% of the miners, actually listened. And they increased the gas limit. And so now the gas limit is up to 10 million. Well, guess what happened? The blockchain is still 100% full. So there's clearly a lot of demand for using the blockchain. That's and the demand is clearly larger than the space that the chain actually has. And so as a result, transaction fees just end up being much higher than they need to be. So this is a problem. Fortunately, this is like scalability is exactly the problem that we've been spending years fixing. So before we get to scalability, another thing that's worth mentioning is proof of stake. So this is phase 0 of Ethereum 2.0 clients to talk to each other. And so now we're going to be very close to having a public Ethereum 2.0 testnet. So 1 year ago, right, Ethereum 2.0 was what really was just an idea, and the spec was kind of just starting to be written. And now the spec is complete, and security issues, and people are building it, and we're very close to having public test networks. So more progress. So scalability. Scalability is, I continue to say, the biggest problem. And it's the biggest problem in part because scalability problems directly limit the number of people who can participate. And it's also a problem because if the number of people who wants to participate is higher than the number of people who can participate, transaction fees go up. And so there's two kinds of scalability solutions, right? One is layer 1 scalability solutions, which basically change the way that the blockchain works to try to increase its capacity. And the other is layer 2 scalability solutions, which keep the blockchain exactly the way it is, but they change the way that applications work so that applications use the blockchain kind of more sparingly and more efficiently, but still benefit from its security. Sharding is a layer 1 scalability technology. So basically the way sharding works is instead of every node verifying every block, every validator in the proof of stake system is randomly assigned to 1 out of 1,024 shards, and they only have to verify all of the blocks in that shard. So scalability, or the capacity of the system, goes up by a factor of 1,024. Right, you go up from 1 shard to 1,024 shards. Security of the system is still pretty high because every single shard still, like the protocol targets it so that every single shard still has about 128 validators that are verifying it and that have to sign off on those blocks for them to be accepted. So. And then after that, we also have some other mechanisms, data availability proofs, fraud proofs, like blind techniques, and all of these other things. So there's kind of multiple things that have to break for the system to accept an invalid block. So that's layer one, right? Now there's also layer two. So one of the kind of there's two interesting recent trends in layer two scalability. One of them is rollups. So a rollup is this kind of halfway scalability solution that's in between layer one and kind of full layer two, such as plasma and state channels. And the way a rollup works is you keep the data on chain, but you put computation off chain. And you only put computation on chain either to verify proofs or if there's a dispute and you need to verify some specific block. Like in the normal case, on the blockchain, you just put data, and you put data in a very compressed form. So for example, about 12 bytes per transaction, and you don't do anything else. So by default, just some amount of data goes on chain, and a bit of proof verification, and no other computation. So rollup, we've done the numbers on it, and currently it can do a theoretical maximum of about 700 transactions per second. And after the Istanbul hard fork, this will go up to about 3,000. And this is on the existing Ethereum chain, right? So if on the existing Ethereum chain, everyone switched to rollup, scalability could go up to 3,000 transactions per second, which is probably already much more than enough for like basically any kind of current and theoretical users for at least some time. Now, of course, at some point, even rollup is not going to be enough, which is why we're doing sharding, which is why we're doing all of these other things. Another big scalability trend is the use of zero-knowledge proofs, right? So Plasma has been worked on for a while, and the holy grail of Plasma is if you did not have to do fraud proofs. Right? Instead, the only thing you had to do like challenge response for is data availability. How do you avoid fraud proofs? Well, you can use snarks, or you can use starks, you can use any of these general purpose proof techniques to basically create proofs that can be verified on chain that allow the system on chain to know that some particular block is valid. So Starkware has this public beta and they're basically working on using a kind of Stark-based version of Plasma to do an exchange. And so far, right now they're still very actively trying to make it more efficient, but it seems to be working well. So that's transactions per second. Rollup is good. So that's scalability technology, right? So sharding can get you up by a factor of about 1,000. Rollup can get you up by a factor of 100. Zero-knowledge proofs can improve things. And they're real, especially in zero-knowledge proofs, right, which are both a scalability technology and a privacy technology. There has been a huge amount of progress in just making it easier to build applications with zero-knowledge proofs. Like basically 2 years ago, to do anything with zero-knowledge proofs, you had to be a cryptographer. And now this is kind of becoming less and less true with every month, right? Like with every month, making applications that use zero-knowledge proofs is becoming closer and closer to looking like just building applications. And this is happening in part because of better protocols. So like Planck got released very recently, and it has some really nice properties. It also really makes the trust setup mechanism much simpler and much more secure. Deep fry, also some improvements to Starks that make them much more scalable and fit in a much smaller size. So a lot of good technical progress. And also good application level progress, right? So there are now Ethereum-based applications that are using zero-knowledge proofs to provide privacy to their users on mainnet. And this has existed for at least a month. So one of the first ones is that there's mixers. And then there are other things under development. So for example, Semaphore Private DAO, which is basically a DAO designed where using zero knowledge proofs, votes are private by default. So a lot of improvements on the privacy side too. So we have more scalability, and we're on the path to getting much more scalability. Where we have privacy, we're on the path to getting much more privacy. Aside from